Okay, for today, the goal is to change a general form into a factored form. Doesn't that just mean to factor it? Yeah, pretty much. We're going to talk it through thoroughly, but it is a really easy day, so we have definitely a bunch of review at the beginning, which is actually more important. So, here is your first slide. You might look at this and say, but wait, Mr. Surver, you must not have looked very closely because f of 9 isn't on here. Is that a true statement? Is f of 9 not on the graph? Yeah, that is a true statement. F of 9 is not on the graph. But that doesn't mean you couldn't answer the question. What is f of 9? You just have to write the equation first. Everybody take a moment and either use the vertex or the two roots and write the equation. I can see that if I go over one and down one that there's a dot there, which means to me that's not been stretched. So I don't have to worry about a stretch. Write it with either the vertex or the roots. And it's kind of like a little personality test. We'll see which one you pick. I'll pause for a second while you give that a try. Then, by the way, once you write the equation, figure out f of 9 is. That's the whole point. Okay, I'm going to pause. I have my first volunteer to do it the factoring way. What was the factors you used? X plus 1 and x minus 3. Raise your hand if you got the same thing. Okay, who did it the other way? Raise your hand if you did it the other way. By the way, if you were going to use factors, she did it right. That's the right answer. But there's another way to do it, which is with the vertex. Who are the vertex people? I have this strange correlation that everybody who did it with the vertex is a straight A student. And that happened last hour, too. I don't know what that means. I don't know if that means that it's better to do it with the vertex or if just that's, I don't know. I don't know what that means. All right, what do you say, ma'am?
X minus 1 squared plus 4.
Okay. I am not trying to say that that's a far superior way to do it. I'm just saying there's an interesting correlation there. Now, there are a lot of A students here. Oh, and if I said that wrong, I apologize. And that is a 4, and that's a positive 4, and then this is a positive. I do have a negative in there. Oh, you mean the negative in the front? Oh, okay, my bad. Okay, yes, there's a negative here and there's a negative here on both equations. They both need a negative in front. Let's be honest. You saw me forget it. How many of you forgot the negative in there? All right, thank you for being honest. Okay, so it's apparently not a half the class thing, but it was a good 5 or 6 of us that did. It's easy to forget the things upside down. And if you forget that negative on the test, you just lost the whole point. Like, I can't give you just partial credit for that. So that's a big deal. All right, now how would you have known that it worked or didn't work? Hint, my recommendation is that you actually put in a point and not the point you used to make it. Do you get what I'm saying by that? Put in a point in your equation and not the point you used to make it. Like if it's the vertex form, don't stick the vertex in. It kind of collapses your whole equation. So if you use the vertex to make it, then you should put in like 3 comma 0. Do you get that's a way to check yourself before you wreck yourself on the test? Totally is. If I put in 3 0, I would have noticed that, wait a minute, that doesn't equal 0. And I would have noticed there was something wrong, and I would have been able to catch it. Okay? So that's just the XY chart coming back to help us out. Your best friend in graphing. 0, 3 should be on it, or -1, 0, or 1, 4. But remember, don't use the same point you used to make the equation, or it won't work. Okay, let's try one more like that. This time, I'm just going to tell you what the roots are. The roots are 3 and -6. I'll also tell you that it has not been stretched and it has not been flipped. And now, to be able to check and see if this worked or not, I'm going to give you one other point. that's on this graph. But for right now, just write what you think the equation is, and then I'll give you one more point to check and see if yours is working right. I'm going to pause for a second. Okay, what if I told you 1 comma negative 14 is on this graph? You should be able to tell now whether or not your equation works with that. If 1 negative 14 works, I'm not saying it's the vertex, by the way. I didn't say that. I just said this is a point that should be on your graph. Now you can look at your equation. Did your equation work? Raise your hand if your equation worked. Good, then you did it right. And here's the equation you should have had, which would be y equals x minus 3. Notice the opposite of the root is there. And then x plus 6. I did say there was no reflect and there was no stretch. I would have had to tell you that, otherwise you can't tell. All right. Now, imagine for a moment that this next one was a test question. See if you'd get it right. Try this one. It's got a light yellow background. I'll pause for a second while you give it a try. Remember to answer it exactly what they've asked you for. Yep. So, imagine it was a test question and you had written this, y equals x plus 4 and x minus 2, and you were feeling pretty confident that you had it right. You might want to just reread the question, because it says, write the equation for the graph in vertex form. Whoa, vertex form. Okay, then that's not vertex form. So what would you do? I personally would have gone and made a quick sketch of it, because I've gotten good at saying, all right, well, let me see what it looks like. So it looks like this, and it says there's no stretches or shrinks, so then it must be like this. Oh yeah, that's right. We can do that deal where we find the line that runs down the middle. What's that line that runs down the middle called? Axis of symmetry. The axis of symmetry. Do you remember it was the average of these two? So you'd average those two together, which is add them together, makes negative 2. Divide by 2, because when you divide by how many there are. And you get negative 1, and x equals negative 1 was the axis of symmetry. Now I know it's negative 1 comma something is the vertex. How do you get the other part? Plug it in. You plug in the negative 1 back in here would be the smart place. 3, negative 3. In factored form, you'll notice that happens. It's kind of strange, but it always happens that way. So it's opposite. So 3 times negative 3, negative 9. Raise your hand if you had negative 1, negative 9 as the vertex. Okay, awesome. But wait. It asked for it in vertex form. Is that vertex form? No, that's the vertex. So now what's the equation in vertex form? Y equals x plus 1 squared minus 9. Now I think I've got it. How should I, if my grade depends on this, because you get how this works? If you make one dumb mistake, you get a free mistake. But if you make another dumb mistake on your test, now you're probably dropping to a B. Isn't it worth taking a second to check? Do you get how it wouldn't take that long to check? I just had to grab a point. What was a point? Well, this was a point. 2, 0. If I put in a 2, I ought to get a 0. Let's find out if I do. So I'll put a 2 and a 0 in. Did it really work? Yeah, it worked. So yay. Because 2 plus 1 is 3, 3 squared is 9, 9 minus 9 is 0. It worked. So I'm confident now that I've got the right equation. So take the time to check your work. All right, let's move on to the next page. This is giving you a way that I don't think is a good idea. It's saying that things that you use as factors will multiply to this and add to that. I think I've told you before that I really don't like that, because I know where we're going next, and that rule is a one-trick pony. It'll only work once. When factoring gets complicated, it won't work. So again, I don't want you to do this. What are the factors? What do they add up to thing? In my opinion, not a great idea. Let me show you why. Let's do this one. Factor it. X and x, and what multiplies to 4 is what you should be. Don't think about the 5. Just what multiplies to 4. 4 and 1. And there is a 2 and a 2 option, isn't there? But here's the thing you should check. Not do these numbers add to this, but do the outside and inside add to that? What I mean is this times this and this times this. Why is that better? Because soon there'll be like a 2 here. Do you get what I'm saying? If there's a 2 here, then that little trick of they'd add to the middle doesn't work. But my little thing of multiply it all the way out will always work for every kind of factoring. If you ever want to factor, this will work. Okay, so I think tricks that work every time isn't really a trick anymore. Then it's just like a way to do the problem. All right, so is this the right answer? X plus 4x plus 1? It is, because this makes 1x, this makes 4x, total of 5x. Yay, I've got it right. All right, everybody try this next one. We'll just get one more under your belt. That's a nice, easy one. And then I'm going to throw you one that's got a leading coefficient that's bigger than 1. So in other words, a harder one to factor. I sense you're already done, sir. What do you get?
I got x minus 4, x minus 4.
All right, and how do you know you're right?
Because I factored it back out.
Yeah, it's not called factoring it back out, but called multiplying back out. Yes, you multiplied it back out, and you made sure it especially made this middle term. And it does, so you're right. Awesome. Now, everybody try this one. 2x squared plus 3x plus 1. And you'll get why I don't like that other little rule, because these will multiply to 1, but they will not add to 3. So that trick only works when you do an easy factoring. Did you get 2x and x? Did you get plus and plus? And then there's only one thing. It has to be a 1 and a 1. Is it guaranteed to work? No. You have to check it and make sure it actually works, because there are things that are prime and won't factor. This one does work. Put them together. 2x times 1 makes 2x. 1 times x makes x. Put them together, you got 3x. Yay. But notice, 1 plus 1 does not equal 3. So that's a bad rule. And here's the other reason that I don't like that rule at all, is because kids come into my class and they think, well, they either multiply to this one or they multiply to that one. They can't remember which one they multiplied to. And if we just kept it simple and there was only one thing, and it was always the n number, and you just had to find something that would multiply to this, then I don't think there would be as much confusion, because right now they know it multiplies to 1 and adds to 1, but I can't remember which one's which. But if there was only one number to focus on, that one, then I think you're less likely to forget the pattern. Okay, I'm just trying to tell you why I don't, and obviously you're hearing in the background, don't do that, because we're getting tomorrow to the hard ones, and tomorrow that little rule wouldn't work for you. But the rule I just taught you about the outside and the inside, that'll keep working even up to when it's x to the third and x to the fifth, and you can multiply them all the way out to see if they worked. That'll always be true. Okay, moving on. Next page. Is it possible we'll get to one that won't work? Yes, and when it does, you will just say it's prime. Because either things factor or they don't. If they factor, they're not prime. Did you get x plus 4 and x minus 1? Raise your hand if you did. Okay, awesome. And the last one here, x, and then what multiplies to negative 12 is all that matters right now. I know, there's a lot of things. 1 and 12, 2 and 6, 3 and 4. Now, you can do it in your head real quick and go, if I put a 1 and a 12, do you think there's any chance that I can, with the outside and the inside, make a 1? No. So then I'm probably thinking it's a 4 and a 3. So I know that means I'm kind of looking at the middle term. Well, of course, it is about the middle term. But don't think that they have to add to that, because tomorrow they won't, because there'll be a number in front. All right, so did you figure out as a 4 and a 3? Raise your hand if you had a 4 and a 3. Okay, and which one's positive, the 4 or the 3? Now, if you ever thought, I've got it backwards, and I check it and I go, wait a minute, I'm getting positive x where I wanted a negative x. You ever get the exact opposite of what you want? Then you have the exact opposite signs as what you want. If you ever get the opposite of what you want, switch the signs around. If you ever get a completely different number than you were supposed to here, then you can't just switch the signs around. You're going to have to switch numbers. So like instead of 4 and 3, you'd have to pick 6 and 2 or something like that. All right, let's move on to the next page. This kind has got a GCF, a greatest common factor. You may remember it from the first 20. Now, a lot of people try to do the factoring all in one step. Don't. Just get a GCF factored out. Did you notice they all had a 3 in them? Then just take that out. Don't try to do the 2 parentheses yet. Just take out the 3. Then you can do 2 parentheses. It's way too hard to do in your head. You need to take out the 3 first. Who's got it? X plus what? X plus what? Say it if you know it. 4 and 2. And I'm double checking that the outside and the inside make the middle, and they do. That's the rule, because that'll work even when there's a number up in front. Outside and inside. All right, how about this one with the negative in the front? Pro tip, always factor out the negative. You could just take a 2 out of each of these, but that's not the best way. You want to always take out a negative. If there's a negative in the front, it's a pain to factor. But once you get it factored out, it's no big deal. Choo-choo. What'd you get? X and X, and then what? Minus 6, minus 1, double checking. Oh, plus 6, okay. Plus 6, minus 1, double checking you. Outside, inside. That makes positive 6x minus 1x makes, dang, that came out to positive 5x. Exact opposite of what you wanted. Oh, sorry. Must be something wrong here. I'm going to back up. I'm hearing a lot of rumbling, which usually means you're doing something wrong, server. What'd I miss? Oh, it's positive 5x. Thank you. Okay, now you are right. Now it will work the way you said it. Thank you. And now, what if my life depended on this answer being right? I would take a second and multiply it all the way out, make sure it equaled that. I'm not going to right now because I understand you're not going to do that on every homework problem. But do you get when there's a test and there's only like 2 that are on factoring, it's probably worth multiplying it all the way out, making sure it works. Kids are often overconfident. United States, in those international studies where they rank us on things, you know what we're best at in the world? Confidence. I can do it. Okay, we're really good at that. So the sad part is you're like, yeah, I know I did it right, and I'm not going to even check it, and I'm going to move on. And then you're going to get it wrong because you like missed one little negative or something. You know what I mean? So kids tend to be a little overconfident. It goes into a lot of areas like, no, I think I can make the jump from the roof to the pool. And no, you just broke your ankle. Or I think I can make this jump even though it's a brand new snowboard and I've never gone down the hill with it before, but I'm feeling it. I think I can do it. Here goes an ankle. Actually, it's probably not your ankle. It's probably your wrists on the snowboard. Okay, moving on. All I'm trying to say is check yourself. All right, this one. What factors out? 4 does. And don't even try to factor it till you got that out. x squared minus what's left? 3x. Oh, wait, there's something else in both of them. What do both of them have in it? X. And then I take out a 4x. And it must be x minus 3. That's weird factoring, but it's right. There was a 4x in both of them. This is factored form, yes. Would it make you feel any better if I said 4x plus 0 and x minus 3? Does it look more like factored form now? Okay, but do you get how that 4x really didn't need me to add 0 to it and put a parenthesis around it? But if it makes you feel better, you could. But it is factored form. I know you really want 2 parentheses, but you don't have to. You can get it done with just 1 parenthesis. All right. Almost done, and we are done. Yay. Okay. This assignment, I decided that odds would be good enough. I'm cutting the assignment exactly in half. I just asked that you do your part and actually do that other half. I have not put a Dropbox up because I want you to grade it in class tomorrow before we Dropbox it. So now I'm not promising that we're for sure going to grade it in class tomorrow. If there's something that's going to take a really long lesson, maybe I won't grade it in class. But my point is, just because there's no Dropbox does not mean you shouldn't do it. It means we're probably grading it in class first and then Dropboxing it. Okay, so keep getting your homework done. Moral of the story there. All right. That's all I got for the video for today.